This is the 12th video supplement for CIS 351, Grand Valley State University's course on computer organization and assembly language. In this video, we'll talk about the concept of propagation delay. In the next video, we'll see how to apply the concept of propagation delay to measure the time needed for entire circuits. Consider the is prime circuit from video 1. In this picture, the switches are providing an input of 13 and the output light is on because 13 is prime. But what happens when we turn the rightmost switch off, thereby changing the input from 13 to 14? Well, of course, the light should eventually go out because 14 isn't prime, but when does the light go out? It doesn't take very long. In fact, it happens so quickly that we can't perceive a delay, but it's not instant. This time needed for a circuit to generate a new output in response to a change in the input is called the propagation delay. Specifically, the propagation delay is the time we must wait after changing the input, or in this example, flipping a switch, before the output is guaranteed to have its final value. Notice there's an important distinction here between hardware and software. In the context of software, it's not unusual for a program to produce no output until the very end, and you can typically use that output as soon as it's produced. For example, here's a program that sorts a bunch of random numbers. Notice that when I launch the program, nothing happens for a few seconds, and then suddenly a bunch of sorted numbers appear. It's perfectly obvious when the output isn't ready because, well, there's no output. And then as soon as we see it, we can use it. With circuits, however, you have to be more careful because a circuit is always producing some form of output. For example, let's say you flip the rightmost switch on this is prime circuit, changing the input from 13 to 14, then almost instantaneously measure the output and see that the light's on. Well, how do you know whether the circuit is telling you that 14 is prime, or whether you just didn't wait long enough for the circuit to figure out the new answer and turn the light off? Well, you can't, which is why you have to make sure you wait through the entire propagation delay before measuring the output. Let me also point out two more things. First, although we present the output of circuits as either a clear true or false, the output is actually a voltage. We interpret high voltage as true and low voltage as false. And we even leave a gap between these two designated high voltage and low voltage regions so that whatever we measure is clearly true or false. Logic gates are designed so that they don't produce voltages in this space between true and false. However, the output doesn't instantly change. So if you read the output too soon, you may end up seeing a value in this transition zone. Second, this transition between values isn't always as smooth as this diagram suggests. It may bounce around a bit and actually look more like this. So just because you see the output change doesn't mean you're seeing the final answer. It may change again. The bottom line is you can't use a circuit's output until the entire propagation delay has elapsed. So in summary, a circuit's propagation delay is the maximum time from when an input changes until the output is guaranteed to have the correct final value. But during that time, the circuit will still have some value on its output. So if you read that output before the entire propagation delay has elapsed, you might get an incorrect or even nonsensical value. In the next video, we'll see how to combine the propagation delays of individual components to figure out the propagation delay of an entire circuit.